Welcome to Professional Tier. This is where your API stops being a toy and starts handling real traffic. Up through Lesson 9, every handler you wrote was a regular def, blocking one worker per request. Lesson 10 changes that. Async def lets a single worker juggle thousands of concurrent I/O calls, and background tasks lets you ship the response first, then do the slow stuff afterward. The whole lesson comes down to one rule. Don't make the user wait. Here are the 4 mental models you'll walk away with, and each one can swing a single worker from 50 requests per second to 5,000. First, knowing when to reach for async def versus a plain def. Get that wrong and you've either wasted the runtime or worse, blocked the event loop. Then, await for non-blocking I/O, background tasks for fire and forget work like emails and logs, and asyncio.gather to run independent calls in parallel instead of stacking them end to end. 4 patterns, 1 theme. Don't make the user wait. So let's start with the most important rule. Match the function type to the work. I/O bound. Waiting on a database, an HTTP call, a file read. Use async def, because every await hands control back to the event loop and lets other requests progress. CPU-bound work, like resizing an image. Plain def, FastAPI will offload it to a thread pool automatically. And here's the trap. Calling synchronous requests. Get inside an async def blocks the entire event loop. Every other concurrent request just sits and waits. Get this one decision right, and everything else in the lesson falls into place. Which means your library choice matters as much as the keyword. Swap requests for httpx.AsyncClient, and suddenly that weather call awaits cleanly. While it sleeps on the network, the same worker is serving hundreds of other requests. One Unicorn worker can comfortably handle 5,000 concurrent connections this way. Same story for the database with Async PG, files with aiofiles, Mongo with motor. The rule is brutal and simple. If you're inside an async def, every I/O call must await. A sync library here is a silent performance killer. No error, no warning, just collapsed throughput. But awaiting isn't always enough. Sometimes the work itself shouldn't block the response at all. Take sign-up. You create the user in 50 milliseconds, but the welcome email takes 2 full seconds over SMTP. Why punish the client for that? Inject background tasks. Call bg.addTask with your function and its arguments, and FastAPI runs it after the response ships. The user sees a snappy 201. The email lands a moment later. For heavier or distributed work, you graduate to Celery or Redis queue, but for fire and forget side effects, this one line is the senior move. Now here's the speed up most APIs leave on the table. A dashboard endpoint typically fans out. Fetch the user, their billing, their usage stats. Awaited in sequence, those 3 200-millisecond calls stack to 600. Wrap them in asyncio.gather and they run concurrently on the event loop, so your total time collapses to the slowest single call, 200 milliseconds, a clean 3x win for one line of code. Speed inside a request is one half of the equation. The other half is not paying setup costs on every request. Opening a Redis connection or spinning up an HTTP client per call will wreck your tail latency. The Lifespan Context Manager fixes that. Everything before yield runs once at startup, everything after runs at shutdown, and the app uses those shared clients in between. This is the modern pattern. App on event is deprecated, so reach for Lifespan instead. Lifespan rolls into a bigger picture. 6 reflexes that separate async, that scales from async, that just hides bugs. Always pick async libraries, because one sync call poisons the whole event loop. Use background tasks for sub-30-second fire and forget, but reach for Celery when the work is critical. Gather any 2 awaitables with no dependency between them. That's your free 2 to 3x speed up. Time out every external call, and when you're stuck with a legacy sync library, asyncio.thread is your escape hatch. Pin this one. 12 patterns. The whole lesson on a single page. When to reach for async def versus plain def, the async clients you'll actually use like httpx and aiofiles, and the 3 concurrency moves: background tasks for fire and forget, asyncio.gather for parallel calls, and to thread when you're stuck with sync code, plus the lifespan trio for shared resources. Keep this open while you code. Now the failure modes. 5 mistakes that pass code review and quietly destroy your throughput. Number 1 is the classic: calling requests, get inside an async def. One blocking call freezes the entire event loop, and your 5,000 RPS becomes 50. Forgetting await is the silent twin. You get a coroutine object back, no error, no request. Heavy CPU work belongs in a thread, not an async handler. Background tasks is fine for logging, but never for charging a card. That's Celery's job. And always set an explicit timeout on httpx, or one slow upstream will hang your endpoint for minutes. Time to put it into practice. 3 exercises in order of impact. First, take any endpoint using requests, swap in httpx.AsyncClient, mark it async def, and benchmark. You'll watch throughput jump 10 to 50 times on the same box. Second, build a sign-up that fires the welcome email through background tasks, so the client gets a 50-millisecond response while the slow SMTP runs after. Third, a dashboard that fans out to 3 services. Sequential is 600 milliseconds. Asyncio.gather brings it to 200. Do these 3, and your API is production ready. And that's lesson 10 in the bag. You've got the 4 pillars of async FastAPI: async await, background tasks, asyncio.gather, and lifespan, which is the dividing line between hobby APIs and production ones. Next up, lesson 11, PyTest, with httpx AsyncClient for fast in-memory tests and a multi-stage Docker file around 80 megabytes ready to ship. See you there.